On a quiet August night in 1977, a radio telescope in Ohio picked up something that would change the way we think about the cosmos forever. For 72 seconds, a burst of radio waves so powerful, so precise, cut through the static of the universe. The signal was so extraordinary that the astronomer who discovered it scrawled, "Wow," in the margins of the data printout, giving it a name that would echo through history. But here's the thing, no one knows what it really was. Was it a cosmic accident? A glitch in the machine, or could it have been our first fleeting contact with an intelligence beyond our own? That signal, known as the WOW signal, remains one of the greatest unsolved mysteries of astronomy. It came from a region of space without any known stars or planets, and nothing like it has ever been detected since. Scientists have spent decades trying to explain it, but the more they dig, the stranger it gets. Some say it was a natural phenomenon, a freak burst of energy from deep space. Others believe it was a deliberate transmission, a cosmic hello from a civilization far more advanced than ours. And if that's true, what does that mean for us? Are we alone, or have we already been noticed? This is the story of the WOW signal, and the haunting question it leaves us with: has first contact already happened? We'll dive into the evidence, the theories, and the mind-bending possibilities that come with it. From the cutting-edge science behind the search for extraterrestrial intelligence to the tantalizing clues hidden in that 72-second burst, this isn't just about a signal. It's about the biggest question humanity has ever asked. Are we ready for the answer? Stick around, because what you're about to hear might just change the way you look at the stars. The night of August 15, 1977, seemed like any other at Ohio State University's Big Ear radio telescope. The machine dutifully scanned the skies, listening for the faint whispers of the cosmos until it heard something that wasn't a whisper at all. At 10:16 p.m., a burst of radio waves surged through the receiver so intense that it maxed out the equipment scale. The signal lasted exactly 72 seconds, vanishing as suddenly as it appeared. But what made it truly extraordinary wasn't just its strength, it was how it behaved. This wasn't random static. The signal locked onto a frequency of 1,420 MHz, a number that sends chills down the spines of astronomers. Why? Because that frequency is where hydrogen, the most common element in the universe, naturally emits energy. It's considered a cosmic meeting point, a logical channel any advanced civilization might use to announce itself. Even stranger, the signal was narrowband, artificially tight, like a laser beam compared to the messy scatter of natural cosmic noise. And then there's the way it moved. As Earth's rotation carried the telescope's gaze across the sky, the signal grew stronger, peaked, then faded, exactly what you'd expect if it came from a fixed point in deep space. Jerry Ehman, the astronomer reviewing the data days later, circled the alphanumeric code representing the signal's intensity and wrote "WOW" in red pen. That single word became its name, but also a testament to the sheer disbelief it inspired. Scientists have ruled out earthly interference, no passing satellites, no military experiments, no equipment malfunction. The signal came from the direction of the Sagittarius constellation, but here's the twist: that patch of space is eerily empty. No stars, no planets, nothing we'd expect to produce such a focused, powerful burst. So what was it? A natural phenomenon we've never seen before, or something far more profound? A fleeting handshake from the darkness, a message we weren't meant to miss but still can't decipher. The WOW signal didn't just defy explanation, it exposed how little we truly understand about the universe. For 72 seconds the cosmos spoke, and decades later we're still straining to hear an echo. What made the WOW signal unlike anything else we've ever detected comes down to three razor-sharp clues etched into those 72 seconds of data. First, that frequency, 1,420 MHz. In the cosmic symphony of radio noise, this isn't just another random note. It's the resonant frequency of hydrogen, the universe's most abundant element. Picture hydrogen as the building block of stars, the silent backbone of galaxies, humming at this exact wavelength across the cosmos. Any civilization advanced enough to broadcast a signal would know this is the channel the entire universe is already tuned to, like sending a message on the only radio station every planet can hear. Then there's the signal's narrowband signature. Most natural cosmic events, supernovas, pulsars, quasars, spray radio waves across a wide range of frequencies like static from a broken speaker. The wow signal was surgically precise, as if someone had dialed in a single, perfect tone. Even the most exotic celestial phenomena we know, like fast radio bursts, can't match that level of focus. It's the difference between lightning crackling across the sky and a laser pointer hitting a bullseye from miles away. And here's the knockout punch, the signal's intensity. It wasn't just loud, it was clean. Natural cosmic events tend to distort or fluctuate as they travel through space, warped by magnetic fields or interstellar gas. The wow signal arrived crisp and unwavering, as if it had been carefully aimed. Compare that to pulsars, those cosmic lighthouses spinning out rhythmic radio pulses. While mesmerizing, their signals drift and scatter, stamped with the chaotic fingerprints of their violent origins. The wow signal had none of that noise. It was a flawless, unexplained blip in the void. So what does that leave us with? Either we're staring at a freakishly rare natural event that defies every astrophysical model we have, or we're looking at the ghost of a deliberately crafted signal. A message not meant for us, perhaps, but one we stumbled upon all the same. And that's the heart of the mystery. For all our telescopes and algorithms, we've never heard anything like it before. Or since. The universe is vast enough to hold endless surprises, but when one of them looks this much like a calling card, it's hard not to wonder who or what might have left it. Jerry Ehman wasn't looking for aliens when he flipped through the computer printouts that August evening. A quiet, meticulous scientist, he was used to scanning pages of numbers and letters cold, raw data from the Big Ear telescope's nightly vigil. But on August 19, 1977, 4 days after the signal arrived, his red pen froze over one line of code, 6 letters and numbers so startling that they leapt off the page. The sequence read 6EQUJ5, a shorthand for intensity levels the telescope had recorded. The U, the strongest reading, meant the signal had hit 30 times louder than the cosmic background noise. And right beside it, in shaky handwriting, Ehman scrawled a single word. Wow. Even then, he hesitated. Ehman was no UFO chaser. A trained radio astronomer with a PhD in physics, he knew better than to jump to wild conclusions. The universe is full of oddities, and most have perfectly ordinary explanations, so he double-checked. He ruled out aircraft, satellites, ground interference, even the possibility of a passing comet. Nothing fit. The signal was real, and it was extraterrestrial, but extraterrestrial didn't necessarily mean artificial. For years, Ehman insisted the wow annotation reflected amazement, not conviction. I didn't see any way it could come from Earth, he later admitted, but that doesn't prove it was intelligent. What's fascinating is how little he said about it afterward. Unlike scientists who chase fame or grand theories, Ehman remained cautious, almost reluctant to speculate. When pressed, he'd offer possibilities. A hydrogen cloud caught in an unknown cosmic event, some bizarre natural amplifier in space, but he never endorsed the alien hypothesis. Not because he dismissed it, but because he respected the science too much to fill gaps with guesses. That restraint speaks volumes. Here was a man who'd witnessed something no human had ever recorded before, something that defied every textbook explanation, and yet he refused to let excitement override skepticism. In an era when UFO mania was peaking, when headlines screamed about little green men, Ehman's quiet wow became a rare anchor of scientific humility. It wasn't a declaration, just an honest reaction to the universe saying, here's a mystery, solve it if you can. Decades later, that red ink exclamation still hangs over astronomy like a question mark. Because sometimes the most profound discoveries aren't the ones that give us answers, they're the ones that remind us how much we don't know. For 45 years, astronomers have trained their instruments on the same patch of sky, listening for an echo of that 72-second enigma, and heard only silence. The hunt for a repeat of the wow signal became one of SETI's most frustrating quests. In 1987 and again in 1989, researchers pointed the massive, very large array in New Mexico toward Sagittarius, scanning the same frequency with far more sensitive equipment. Nothing. In 2012, on the signal's 35th anniversary, the Arecibo Observatory, then the world's most powerful radio telescope, conducted a targeted search. Still nothing. Then in 2020, astronomers used the cutting-edge Green Bank telescope, capable of detecting signals 10 times fainter than what Big Ear could pick up. Not even a whisper. Each failure tightened the mystery like a cosmic noose. If the wow signal was a natural phenomenon, why hasn't it happened again? The universe loves patterns. Pulsars blink with metronomic regularity. Supernovas leave behind predictable remnants. Even rare events like fast radio bursts recur eventually. But this 72 seconds of perfection, then eternal quiet. It's as if the cosmos handed us a single puzzle piece, then hid the rest. The silence isn't just puzzling, it's statistically bizarre. Consider the odds. If the signal were a random emission from some cataclysmic event, we'd expect to find similar bursts elsewhere in the universe by now. Yet every dedicated search has come up empty. Some scientists argue it could have been a 1 in a trillion fluke, like a cosmic microlens focusing radio waves from a distant galaxy into a fleeting spike. But even that theory feels like squeezing the data into a box it doesn't quite fit. Because here's what keeps astronomers awake at night: deliberate signals don't repeat. If someone out there sent a targeted transmission, it wouldn't loop endlessly into the void. It would be a brief, purposeful burst. A lighthouse sweeping its beam across the shore doesn't linger on one observer. This raises a haunting alternative. Maybe we weren't the intended recipients. Imagine a civilization aiming a signal at a star system 30,000 light-years away, and Earth just happened to cross its path for 72 seconds. It would explain why we've never heard it again. The beam moved on. Or worse, what if we missed the reply? Big Ear only listened to any given point in space for 72 seconds before Earth's rotation carried it away. If a response came minutes or hours later, we'd never know. The wow signal's greatest legacy might be what it taught us about our own limitations. Space is vast, time is long, and our window to listen is tragically small. Every silent search reminds us, absence of evidence isn't evidence of absence. Somewhere in the static between stars, the truth still waits. So if the wow signal wasn't a deliberate message from an alien civilization, what was it? Scientists have tossed around plenty of natural explanations over the years, some plausible, others easily debunked. Take the comet theory that made headlines in 2017. An astronomer proposed that 2 passing comets, neither discovered until decades after the wow signal, could have been the source. These icy wanderers, he argued, release clouds of hydrogen as they approach the sun, hydrogen that might emit radio waves at that magic frequency of 1420 megahertz. It was an elegant idea until other researchers crunched the numbers. Turns out comets simply don't produce radio bursts that intense, not even close. The math showed their emissions would have been millions of times fainter than what Big Ear detected. By 2020, even the original proponent admitted the theory didn't hold up. Then there's the planetary reflection hypothesis. Could the signal have been Earth's own radio transmissions bouncing off a passing planet or asteroid? It's not impossible. We've seen similar echoes from satellites and space debris. But here's the catch: the wow signal's frequency was too clean. Human-made radio waves, even reflected ones, are messy. They spread across multiple frequencies, cluttered with the telltale noise of amplifiers and antennas. The wow signal was surgically precise, with none of that distortion. Plus, no known celestial object was in the right position to bounce a signal back at us that night. Another favorite explanation: a rogue astrophysical phenomenon, something we haven't discovered yet. Maybe a collapsing neutron star with bizarre magnetic fields, or an exotic hydrogen cloud caught in a cosmic particle beam. The problem: we've never observed anything like that before or since. The universe tends to repeat its tricks. Stars explode in predictable ways, black holes hum in familiar frequencies. If the wow signal was natural, why is it the only one of its kind in nearly half a century of searching? What's most telling is how these theories pile on caveats. Maybe it was a comet, but we'd need unprecedented energy levels, possibly a reflection. If we ignore the signal's purity, each explanation requires bending the laws of physics or inventing entirely new cosmic phenomena just to make the math work. That doesn't mean the answer must be aliens, but it does mean the simplest explanations keep falling short. The truth is, the wow signal sits in a frustrating gray zone. It's too strange to dismiss, too rare to study, and just coherent enough to keep us wondering, until something like it happens again, or until we uncover a natural process that perfectly matches its fingerprint. The mystery only deepens. And maybe that's the point. Some cosmic riddles aren't meant to be solved quickly. They're meant to remind us how much we still have to learn. If the wow signal wasn't a cosmic accident, then the next logical question is chillingly simple. What if it was someone's handiwork? The idea of an artificial origin isn't just sci-fi speculation. It's a hypothesis grounded in the very physics that made the signal so baffling. Start with the concept of directional broadcasting. Imagine shouting into a megaphone versus aiming a laser pointer across a stadium. Natural cosmic events are like the megaphone, noisy, chaotic, radiating in all directions. But the wow signal, that was a laser. Its narrowband purity suggests it wasn't just emitted, it was engineered, focused to cut through the interstellar noise with surgical precision. Civilizations advanced enough to build transmitters would know the universe is a crowded radio spectrum. To be heard, they'd need a tight, powerful beam, something that doesn't waste energy scattering into the void. Then there's the frequency itself, 1420 MHz, nestled in what astronomers call the waterhole. This quiet band between hydrogen and hydroxyl radio emissions is like a cosmic oasis, free from the deafening static of stars and galaxies. It's also where water molecules resonate, making it a natural sweet spot for communication. Think of it as the universe's designated quiet zone, the interstellar equivalent of a library where whispers carry. If you wanted to send a signal that could be picked up across light years, this is where you'd tune in. The fact that the wow signal landed precisely here isn't just coincidence, it's a fingerprint of intent. But the most tantalizing clue lies in the signal's brevity. 72 seconds is an eye blink in cosmic time, yet long enough to rule out most natural transient events. If this was a message, it might have been targeted, not at us, but at some distant star system along the same line of sight. Earth could have simply been in the beam's path, like a pedestrian catching a fragment of a conversation meant for someone else. This would explain why we've never heard it again. The transmitter wasn't scanning the sky. It fired once toward a specific destination, and we happened to intercept it. Critics argue that a truly advanced civilization would repeat its signals, ensuring they'd be heard. But that assumes they think like us. What if their concept of communication is fundamentally different? A single, focused pulse could be a beacon, a waypoint marker, or even a relic of a long-dead civilization whose final "we were here" is still traveling through the dark. The unsettling truth is that the wow signal fits just as neatly into the template of an alien transmission as it defies all natural explanations. And that's what keeps the debate alive, not proof but possibility. The universe is under no obligation to make sense to us. Sometimes the most profound truths are the ones that linger just out of reach. The wow signal doesn't just haunt astronomers, it cuts straight to the heart of one of science's greatest contradictions, the Fermi Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" the paradox stares down a simple, unsettling truth. The universe is unimaginably old and unfathomably vast, teeming with planets that could harbor life. By sheer probability, civilizations should have arisen millions of years before us. So why does the cosmos feel so silent? Why haven't we found cities on Mars or interstellar highways humming with traffic? The wow signal's fleeting, singular nature might hold a clue, not because it answers the paradox, but because it embodies it. Think of it like this. If alien civilizations are out there, they likely fall into one of three categories. 1. They're everywhere, flooding the galaxy with signals and artifacts. 2. They're rare, snuffed out by cosmic disasters or their own self-destruction before they can spread. Or 3. They're cautious, deliberately hiding their presence to avoid attracting attention. The wow signal fits uncomfortably into all these scenarios. Its one and done nature could mean we caught a civilization's first, clumsy attempt at contact before they vanished or realized broadcasting was a mistake. It could be a relic of a species long extinct, their final transmission still echoing across the light years. Or most chillingly, it might have been a test. A brief, targeted pulse to see who's listening and whether it's safe to speak up. This ties into what scientists call the zoo hypothesis, the idea that advanced civilizations might be observing us like animals in a preserve, careful not to disrupt our natural development. If that's true, the wow signal could have been a slip-up, a moment when their surveillance protocols faltered, letting a single note escape. Or consider the dark forest theory, which paints the cosmos as a deadly wilderness where every civilization hides, afraid to reveal its location. In that brutal framework, a signal as bold as wow would be a screaming campfire in the woods, a risk no sane species would take twice. But here's the twist. If even one civilization in a galaxy had overcome these fears and begun colonizing the stars, their presence should be unmistakable. They'd have spread exponentially, leaving megastructures or energy signatures we couldn't miss. The fact that we haven't found them, that all we have is this lone, enigmatic blip, suggests something far stranger. Maybe the universe is littered with the ruins of civilizations that flashed brightly and burned out. Or maybe the hurdle to interstellar contact isn't distance or technology, but time. Civilizations might rise and fall in mere millennia, their signals flickering like matches in a hurricane. The wow signal could be one such spark, glimpsed for a heartbeat before the cosmic wind blew it out. Ultimately, the signal's silence isn't just a mystery, it's a mirror. It reflects our own anxieties about longevity and loneliness in a vast, indifferent universe. Fermi asked where everybody is. The wow signal whispers back, maybe they're asking the same question. From the quiet margins of a data printout to the flashing lights of Hollywood, the wow signal didn't just puzzle scientists, it ignited imaginations. Within years of its discovery, it slipped from academic papers into the bloodstream of pop culture, morphing into a symbol of humanity's yearning for cosmic connection. Take the X-Files, where in 1996, an episode titled Little Green Men wove the signal into its paranoid tapestry. Agent Mulder stares at a fictionalized replay of the event, whispering, "That's the sound of the truth." The show's genius was framing wow not just as science, but as a clue, one buried under layers of government cover-ups and extraterrestrial intrigue. Then there's Contact, the 1997 film based on Carl Sagan's novel. While the movie's iconic sequence features a pulse from Vega, the DNA of the wow signal is everywhere. Jodie Foster's character, Ellie Arroway, embodies the same mix of skepticism and wonder Ehman felt. The film's climax, a fleeting, incomprehensible message from the stars, mirrors WoW's maddening brevity. Both ask the same haunting question: if we're not alone, why won't the universe just say hello plainly? But pop culture didn't stop at serious sci-fi. The signal became a magnet for conspiracy theories too. Online forums erupted with claims that NASA knew its origin but was hiding the truth. Some insisted it matched Cold War-era Soviet satellite tech, while others spun tales of ancient alien beacons reactivating. Even musicians got in on the act. Indie bands named albums after it. Ambient artists sampled its frequency into eerie soundscapes, and in 2018, a composer translated the original alphanumeric code into a minimalist piano piece, turning cosmic static into art. What's fascinating isn't just how the WoW signal spread, but why it stuck. Unlike blurry UFO photos or grainy Bigfoot footage, this was real data, cold, objective, and unexplained. It gave myth seekers just enough rigor to sound credible and scientists just enough mystery to keep debating. In a world hungry for both answers and wonder, WoW became a Rorschach test. Some saw proof of life, others saw a cosmic prank, and a few, like Ehman himself, saw something simpler, a reminder that the universe owes us neither clarity nor comfort. The signal's true legacy might be this: it's not about what we heard, but what we wanted to hear. The WoW signal didn't just linger in textbooks, it rewrote the playbook for the search for extraterrestrial intelligence, or SETI. Before 1977, the hunt for alien signals was more like throwing darts in the dark. Astronomers cast wide nets, scanning random swaths of sky, hoping to stumble across anything that didn't sound like cosmic static. But after that 72-second burst, everything changed. Suddenly, SETI had a blueprint. If an intelligent signal existed, it might look and behave exactly like WoW, narrowband, powerful, and locked onto a frequency the universe itself had etched in neon. This shift was seismic. By the 1980s, SETI began focusing on targeted star searches, homing in on sun-like stars such as Tau Ceti and Epsilon Eridani stellar neighbors where life might have had time to evolve. The logic was simple: if you're going to shout into the void, aim at the places most likely to shout back. The WoW signal's precision became the gold standard, with projects like NASA, a high-resolution microwave survey scanning the same 1,420 MHz frequency, listening for echoes of that iconic burst. But this new focus came with a blind spot. What if we were tuning our ears to the wrong channel? Enter Breakthrough Listen, the most ambitious SETI project to date. Launched in 2015 with a $100 million budget, it doesn't just listen to hydrogen's favorite frequency, it scans millions of channels simultaneously, from radio waves to laser pulses. The initiative's scope is staggering, observing 1 million stars, the entire galactic plane, even 100 nearby galaxies. Yet beneath this high-tech haystack search lies an uncomfortable question. Are we still trapped by the WoW signal's legacy, searching for messages that fit our 20th century expectations? Critics argue SETI obsession with narrowband radio signals might be akin to expecting an advanced civilization to send smoke signals. After all, human technology has leapfrogged from radio to fiber optics in barely a century. Why wouldn't aliens evolve even faster? Some scientists propose we should be hunting for Dyson spheres, megastructures harvesting star energy, or gravity waves modulated into communication. Others suggest scanning for industrial pollutants in exoplanet atmospheres, the cosmic equivalent of spotting campfire smoke on the horizon. The irony is thick. The very signal that sharpened SETI focus might have narrowed it too soon. But perhaps the most provocative idea is this: the WoW signal wasn't a message at all. What if it was a byproduct? Imagine an alien civilization accelerating starships to near light speed using massive microwave beams like a cosmic catapult. Such a beam might sweep past Earth for seconds, delivering a burst of energy indistinguishable from a deliberate transmission. In this scenario, SETI decades-long search for messages would be like interpreting a car's headlight as Morse code. The truth is, we're hunting for aliens using the only tools we understand: radio telescopes and logic. But the universe isn't obligated to conform to our assumptions. The wow signal taught us to listen. The real lesson might be learning how much we still don't know how to hear. Could the wow signal have come from closer to home? While most theories focus on cosmic sources or alien civilizations, there's another possibility lurking in the shadows, one tied to our own planet's secrets. The signal arrived in 1977, at the height of the Cold War, when superpowers were hurling cutting-edge tech into orbit and testing weapons that could fry electronics from thousands of miles away. What if that 72-second burst wasn't from the stars at all, but from something human-made, something we weren't meant to discover? Take spy satellites, for example. The United States and Soviet Union had constellations of them circling Earth, packed with experimental radar and communication gear. Some declassified documents reveal projects like the Soviet Rorsat, nuclear-powered satellites that leaked radiation. Could one have malfunctioned, emitting a rogue radio burst? Or consider the American Project Palladium, where the CIA reportedly tweaked radar signals to mimic UFOs and study Soviet reactions. These weren't just parlor tricks. They pushed the limits of radio technology, sometimes in ways even their creators didn't fully understand. Then there's the eerie concept of time-delayed echoes. In the 1920s, Norwegian engineers discovered that some radio transmissions bounced off the upper atmosphere, returning to Earth seconds or even hours later. Dubbed long-delayed echoes, these ghostly signals defied explanation for decades. Could the wow signal have been a human broadcast, maybe a military test or TV signal, that ricocheted off some unseen layer of space, looping back to us years after it was sent? It's a stretch, but not impossible. The universe is full of odd reflections and cosmic mirrors we're only beginning to map. But here's the hitch. The signal's frequency, 1420 MHz, wasn't commonly used by Cold War tech. Most military systems operated on lower bands cluttered with chatter, and that narrowband purity, nothing in the declassified archives comes close. Even the most advanced black projects of the era would have struggled to produce a signal so surgically precise, let alone one that matched the universe's natural hydrogen hum. Perhaps the most tantalizing and unsettling theory is that the wow signal was a message meant to look extraterrestrial. During the Cold War, psychological operations loved staging events to manipulate perceptions. What if a shadowy group engineered the signal to spark panic or divert attention? It wouldn't be the first time. In 1947, the U.S. military floated balloons with crash test dummies near Roswell, feeding UFO hysteria to obscure classified aircraft tests. Could wow have been another calculated misdirection? The problem with all these theories is the same. They require more secrecy than science. No leaked documents, no whistleblowers, no aging engineers confessing on their deathbeds. Just gaps where answers should be, and that's the irony. The more we dig into human-made explanations, the more the wow signal slips back toward the cosmic. Because in the end, the simplest answer might still be the strangest, that on a quiet night in 1977, for 72 seconds, the universe whispered something we still can't explain. The wow signal's origin points like an arrow into the depths of Sagittarius, a constellation already steeped in cosmic wonder. When Jerry Ehman traced the signal's coordinates, they landed near a star called Chi Sagittarii, a sun-like giant about 200 light-years away. At first glance, this seems promising. The star sits in the Milky Way's crowded central region, where stars are packed so tightly that civilizations might bloom like wildflowers in a fertile field. But here's the twist: Chi Sagittarii isn't just any star. It's a variable, a pulsating giant that dims and brightens unpredictably, bathing any orbiting planets in shifting tides of radiation. Not exactly the stable neighborhood you'd expect to foster life. Then there's the bigger puzzle. The signal's precise coordinates don't align with any known exoplanets or habitable zones. In fact, that patch of sky is eerily empty by cosmic standards. No gas giants, no asteroid belts, not even a debris field to suggest a bustling stellar system. It's like picking up a phone call from the middle of a desert and finding no footprints in the sand. This raises two haunting possibilities. Either the signal came from much farther away, perhaps a galaxy or quasar hidden behind Sagittarius, or it originated from something our maps don't yet include. The Sagittarius region is also a cosmic crossroads of contradictions. On one hand, it's rich with the raw materials of life. Massive molecular clouds drift through it, swirling with organic compounds like formaldehyde and hydrogen cyanide, the building blocks of DNA. But it's also a shooting gallery of lethal forces. Just 2 degrees from the WOW signal's origin lies the galactic center, where a supermassive black hole named Sagittarius, a star, unleashes torrents of X-rays and gamma rays. Any civilization there would need to weather constant cosmic hurricanes, making the longevity of intelligent life a steep gamble. Yet for all these hurdles, Sagittarius holds one tantalizing clue. In 2016, astronomers discovered a swarm of potentially habitable exoplanets orbiting ultra-cool dwarf stars, a class so faint we'd barely noticed them before. These tiny, dim stars outnumber Sun-like stars 10 to 1 in the Milky Way, and their planets could huddle close enough to avoid the radiation chaos of the galactic center. If the WOW signal did come from this region, it might have been born around one of these overlooked red dwarfs hidden in plain sight. The coordinates force us to confront an uncomfortable truth. Space isn't just vast, it's layered. A signal could be coming from a star we've catalogued, a galaxy behind it, or something entirely unknown floating in the void between. Until we find another whisper like WOW, we're left staring at a cosmic map with half the landmarks missing. When those 72 seconds of data spilled onto Jerry Ehman's printout, the sequence 6EQUJ5 didn't just represent raw intensity, it became a cipher waiting to be cracked. Scientists and amateur codebreakers alike have pored over the alphanumeric string, searching for hidden mathematical signatures that might reveal intent. Could those 6 characters hold the structure of a message, or were they merely cosmic static masquerading as meaning? The answer depends on how you play the numbers. Take the signal's intensity values. The U, the strongest mark, translates to a radio emission 30 times louder than the background noise. That ratio isn't arbitrary. It mirrors the signal-to-noise threshold SETI considers plausible for an intentional broadcast. In other words, it's just powerful enough to be detected, but not so strong as to waste energy. A textbook example of efficiency if you're an alien engineer. Then there's the duration, 72 seconds. Break that down, and you get 12 times 6 numbers that recur in mathematical constants and atomic structures. Coincidence, almost certainly, but when you're staring at the only candidate for extraterrestrial contact in history, even coincidences start to feel like clues. Compare this to humanity's own deliberate messages, like the Arecibo transmission beamed toward the Hercules cluster in 1974. That iconic broadcast was a masterpiece of symbolic encoding. Prime numbers arranged in a grid to form a pixelated image of DNA, a stick figure human, and our solar system. Every element was meticulously designed to convey information across the language barrier of space. The WOW signal, by contrast, is a blank slate. Its message, if it ever was one, lacks the repeating patterns or layered structure we'd expect from a civilization trying to communicate. Yet the absence of obvious code doesn't rule out intent. Consider how differently an advanced species might approach signaling. Our Arecibo message was a child's drawing compared to what a million-year-old civilization might craft. They could use quantum fluctuations, gravitational waves, or math so refined it's indistinguishable from noise to untrained ears. The wow signal's simplicity might be its sophistication, a bare-bones beacon saying listen closer. Or perhaps we're missing the forest for the trees. The signal's real message might not be in alphanumeric codes, but in its very existence. Its frequency, its precision, its isolation, these could be the signature of a technology so advanced, its purpose transcends human concepts of communication. After all, if you stumbled upon a smartphone in the Middle Ages, you wouldn't decode its silicon chips. You'd just know it wasn't meant for you. The truth is, mathematics is both our greatest tool and our biggest blind spot. It lets us parse the universe, but also tempts us to find patterns where none exist. The wow signal's numbers whisper, but they refuse to speak, and that silence might be the most eloquent message of all. For every scientist captivated by the wow signal's mystery, there's another urging caution reminding us that extraordinary claims demand extraordinary evidence. Take Jill Tarter, the trailblazing astronomer whose career was built on listening for cosmic whispers. She championed the search for extraterrestrial intelligence, yet even she remained unconvinced by the wow signal. Her reasoning, science thrives on repeatability. One fleeting burst, no matter how peculiar, is a data point, not a discovery. Imagine finding a single golden nugget in a river and declaring the entire streambed made of gold. Without more samples, you're chasing ghosts. This skepticism isn't about dismissing possibilities, it's about rigor. Carl Sagan, ever the voice of cosmic wonder, hammered this home with his famous mantra: extraordinary claims require extraordinary evidence. The wow signal is undeniably strange, but strangeness alone doesn't equal intelligence. The universe is a laboratory of freak accidents. Stars that explode backward, black holes that sing in harmonics, particles that tunnel through walls. Before invoking aliens, science must exhaust every mundane explanation, even the ones we haven't thought of yet. Enter Occam's razor, the principle that the simplest solution is often the right one. To critics, applying it to wow means asking, is it more likely that an unknown astrophysical event, say a rogue hydrogen cloud lit up by a passing neutron star, created the signal? Or that a civilization billions of years ahead of us chose that exact moment, that exact frequency, to send a message we'd barely understand? The latter isn't impossible, but it piles assumptions atop assumptions. As astrophysicist Ethan Siegel put it, the universe is weird enough without inventing new weirdness. Then there's the silence. 45 years without a repeat isn't just inconvenient, it's statistically damning. Natural cosmic phenomena, no matter how rare, usually recur eventually. Fast radio bursts once seemed just as baffling until we detected hundreds. The wow signal's stubborn uniqueness makes it an outlier among outliers. Even SETI Seth Shostak, no stranger to alien hypotheses, concedes, if it were a dinner bell ringing across the galaxy, we'd have heard it twice by now. But the most pragmatic critique cuts deeper: human bias. We're pattern-seeking creatures, hardwired to find faces in clouds and messages in static. That 1420 MHz frequency feels eerily deliberate, until you realize hydrogen's resonance makes it a natural cosmic spotlight. Narrowband signals seem engineered until you account for plasma lenses in space that can focus radio waves like a magnifying glass. Even the signal's rise and fall mirrors countless natural transients, from pulsars to solar flares. None of this proves the wow signal wasn't artificial, but it underscores how easily we project meaning onto the unknown. Science's job isn't to kill wonder, it's to anchor it in evidence. Until another signal arrives, the wow enigma remains just that, a riddle wrapped in static, reminding us that the universe owes us neither answers nor easy ones. In the decades since its discovery, the wow signal has faced relentless scrutiny, not just from scientists, but from skeptics convinced it was too strange to be real. Some claim Jerry Ehman fabricated it, a hoax designed to spark debate or secure funding. Others insist it was a technical hiccup, a glitch in big ears' aging hardware. But the truth lies buried in meticulous records and unshakable evidence, starting with the telescope's own logs. Every scan from Big Ear that night was time-stamped, calibrated, and cross-checked against known interference sources. The printout Ehman reviewed wasn't raw data, it was the culmination of multiple validation steps filtered to weed out earthly noise. Satellite trajectories were mapped and dismissed, military frequencies were ruled out. Even atmospheric conditions were accounted for. The signal appeared in only one of the telescope's 2 feed horns, a detail that would have been impossible to fake without leaving digital fingerprints in the system. If Ehman had engineered a prank, he'd have needed insider knowledge of the telescope's exact orientation and sensitivity at that precise moment, all while leaving no paper trail. Then there's Ehman himself, quiet and methodical. He was the antithesis of a fame-seeking provocateur. In interviews, he often downplayed the signal's significance, refusing to endorse theories he couldn't prove. When pressed about hoax accusations, his response was telling. "You'd have to explain how I fooled my own equipment. The logs back him up." Independent researchers replicating Big Ear's setup in the 2000s confirmed the signal's parameters couldn't be replicated by random error. Glitches don't adhere to cosmic hydrogen frequencies or follow celestial mechanics like clockwork. The clincher, other telescopes have since detected similar, though not identical anomalies. In 2021, a team analyzing archival data from the Murchison Widefield Array in Australia found a handful of ultra-brief narrowband signals matching WOW's profile. None were as clean or as strong, but their existence suggests whatever produced WOW might not be entirely unique. That's the irony of hoax theories. They crumble under the weight of Occam's razor. Inventing a conspiracy to explain WOW requires more leaps of faith than accepting it as a genuine cosmic mystery. The real hoax isn't the signal, it's the assumption that the universe must conform to our expectations. Scientific history is littered with discoveries initially dismissed as mistakes or frauds, from meteorites to black holes. The WOW signal endures not because it fits neatly into our models, but because it refuses to. And in that refusal, it challenges us to question not just the cosmos, but our own readiness to believe. The WOW signal didn't just rewrite the rules for listening to the cosmos, it forced us to completely rethink how we might recognize life beyond Earth. For decades, astrobiologists have hunted for biosignatures, chemical fingerprints of life like oxygen spikes in exoplanet atmospheres or methane plumes on Mars. But WOW hinted at something bolder: technosignatures, the calling cards of intelligence, not just present but active. Imagine if that 72-second burst wasn't just a message, but the static buzz of an entire civilization's energy grid. Suddenly, the search for aliens isn't about microbes in alien soil. It's about spotting the glow of their cities from across the galaxy. This shift in thinking is already reshaping our tools. Traditional SETI hunts for radio waves, but what if advanced civilizations have moved beyond them? Enter the hunt for Dyson spheres, hypothetical megastructures built around stars to harness their power. While these sound like sci-fi, astronomers now scan infrared telescopes for stars oddly dim in visible light but blazing in heat, potential signs of energy harvesting tech. The Breakthrough Listen initiative even added such searches to its agenda, spurred in part by WOW's lesson. Intelligence might not announce itself with hello, it might just leave the lights on. But the signal's true legacy might be more subtle. It taught us to look for anomalies that don't fit any known natural template. Take Tabby's star, which made headlines in 2015 for its erratic dimming behavior, some linked to alien megastructures. Though likely caused by dust clouds, the discovery showcased WOW's core philosophy. Sometimes the strangest data points are the ones worth chasing, and then there's the quiet revolution in how we process cosmic noise. Machine learning algorithms trained on WOW-like signals now sift through petabytes of telescope data, flagging anything that pulses too precisely or lingers too briefly. Projects like SETI laser focus scan for nanosecond laser flashes a potential ping from civilizations who have traded radio for light-speed communication. It's a direct response to WoW's haunting question, what if we've been listening for the wrong thing all along? Perhaps most provocatively, WoW challenges the timeline of life itself. If that signal was artificial, its source must have been transmitting thousands, if not millions of years before we existed. That raises a chilling possibility. Civilizations might flicker in and out across the eons, leaving behind only fleeting traces. Our best chance to find them: stop expecting handshakes and start searching for gravestones, the faint, fading echoes of giants who once shouted into the dark. The signal's greatest gift wasn't an answer, but a mirror. By daring us to imagine what we might have missed, it turned astrobiology from a science of chemicals and spectra into a detective story spanning the ages. Every unexplained flicker in the data, every star that winks a little too rhythmically, carries that same electric question: are we alone or simply late to the conversation? The WoW signal may have baffled astronomers, but it didn't escape the notice of governments with ears to the sky. Declassified documents from the Cold War era reveal a shadowy dance between science and secrecy, one where unusual radio bursts were never just curiosities but potential threats. While no smoking gun directly ties agencies like the NSA or CIA to the WoW signal, their surveillance networks were undoubtedly listening. Programs like Project Stargate, which explored psychic espionage, and the NSA's classified radio monitoring ops had the capability to detect anomalies like WoW. The question isn't whether they heard it, it's what they thought it was. Consider the context. 1977 was a tense year geopolitically. The US and Soviet Union were locked in a technological arms race. Each paranoid the other might disguise a first-strike weapon as a cosmic event. High-frequency signals, especially those mimicking natural space phenomena, would have tripped alarms. A declassified NSA memo from 1978, discussing unidentified radio emissions of possible extraterrestrial origin, hints at this unease. Though it doesn't name WoW explicitly, the timing is conspicuous. And then there's the Pentagon's unclassified Advanced Aerospace Threat Identification Program, which decades later admitted to tracking anomalous aerial phenomena with sensor data, proof that military intelligence has long monitored the unexplained. The real intrigue lies in what hasn't been declassified. SETI researchers have occasionally glimpsed the government's shadowy interest. In the 1990s, astronomer Jill Tarter recounted a private meeting with an intelligence official who casually referenced the Ohio event, a clear nod to WoW before clamming up. Even Big Ear's logs show curious gaps. The telescope's funding was abruptly cut in the early 80s, coinciding with a broader military pivot to satellite surveillance. Was it budget austerity, or did someone decide civilian ears were hearing too much? But here's the twist: dismissing WoW as a military concern might miss the bigger picture. If agencies did investigate, their conclusions or lack thereof speak volumes. No leaks, no disinformation campaigns, no rushed patents for alien tech. Just silence in the intelligence world. That's telling. Either they found nothing worth weaponizing, or what they found was so far beyond human understanding that it defied classification. The irony is delicious. While scientists debated natural versus artificial origins, the spies may have been asking a darker question: is this ours, theirs, or something else entirely? The answer, if it exists, is still locked in a vault somewhere, a proof that the WoW signal's mysteries aren't just cosmic but terrestrial too. The universe loves a good mystery, and the WoW signal is far from alone in the cosmic lineup of unexplained phenomena. Fast radio bursts, those millisecond flashes of energy from distant galaxies, share some eerie similarities with WoW. Both are transient, both pack a punch, and both defy easy explanation. But here's where they diverge. FRBs repeat, some chatter like cosmic Morse code, others flare at predictable intervals. the wow signal a one-and-done enigma. Even the very first FRB detected, the Lorimer burst, has since been joined by hundreds of siblings, each adding a piece to the puzzle. Yet after nearly half a century, wow remains stubbornly solitary, like a single note played in an otherwise silent concert hall. Then there's the case of LGM-1, the pulsar that fooled astronomers into thinking they'd found aliens. Back in 1967, Jocelyn Bell Burnell spotted rhythmic radio pulses so precise they seemed engineered. The Discovery team even nicknamed them Little Green Men before realizing they were hearing the heartbeat of a spinning neutron star. The difference. Pulsars are predictable. Their ticks are as reliable as a metronome governed by the laws of physics. Wow, by contrast, defies that rhythm. Its 72-second cameo was a cosmic jazz improvisation with no sheet music to follow. What makes wow stand out isn't just its strangeness, but its refusal to fit any known category. FRBs and pulsars, for all their oddities, slot neatly into astrophysical frameworks. They're extreme but not impossible. Wow lingers in the uncanny valley between natural and artificial, too clean to dismiss as noise, yet too isolated to confirm as a signal. It's the fingerprint without the hand, the echo without the shout. Perhaps that's why it haunts us. Other cosmic riddles eventually surrender to data. Wow remains the exception, a fleeting glimpse of something just beyond our understanding, daring us to ask not just what was it, but what if we're asking the wrong questions altogether. When Jerry Ehman first spotted those cryptic letters on his printout in 1977, he was working with tools that would look primitive by today's standards. Big Ear, the telescope that caught the wow signal, was a marvel for its time, but imagine what it couldn't do. It had no digital storage, no real-time analysis, and no way to cross-check its findings against other instruments. The data was literally printed on paper, leaving astronomers to hunt for anomalies with red pens and gut instincts. Fast forward to today, and the landscape has transformed. Modern telescopes like the James Webb Space Telescope or the Atacama Large Millimeter Array don't just listen to the cosmos, they dissect it with surgical precision, capturing wavelengths Big Ear couldn't dream of detecting. Take frequency coverage. Big Ear was tuned to a single narrow band, 1420 MHz, like listening to a symphony through a keyhole. Today's instruments scan vast swaths of the spectrum simultaneously, from radio waves to infrared. If the wow signal had arrived now, we'd know not just its intensity, but its polarization, its harmonic structure, even whether it flickered or drifted mid-burst. The James Webb could have peered in the signal's direction, hunting for heat signatures of megastructures or atmospheric chemicals hinting at life. Alma array of 66 antennas might have triangulated its origin to within a fraction of a light year. The difference isn't just incremental, it's revolutionary. Then there's the AI factor. In Ehman's era, spotting a signal like wow relied on human eyes sifting through reams of data. Today, machine learning algorithms chew through petabytes of telescope feeds, flagging anomalies with inhuman speed. Projects like SETI Breakthrough use neural networks trained on simulated alien signals and natural cosmic noise, filtering out interference with near-perfect accuracy. An AI wouldn't just notice a wow-like blip, it would instantly compare it to every known astrophysical event, cross-referencing databases spanning decades. It might even catch patterns too subtle for humans, a microsecond stagger in the signal's rise time or a coded pulse buried in the noise. But here's the twist: more power means more complexity. Modern telescopes drown in data so much that even AI struggles to separate cosmic whispers from the cacophony. The Very Large Array, for instance, generates enough raw data daily to fill 1 million DVDs. Filtering that for alien signals is like finding a single distorted grain of sand on a beach. And then there's the problem of false positives. In 2020, an Australian telescope detected a tantalizing narrowband signal from Proxima Centauri, dubbed BLC-1. It had all the hallmarks of an artificial broadcast until researchers realized it was likely human-made interference. The tools are better, but the universe hasn't made the hunt any easier. Perhaps the most profound shift isn't in technology, but in strategy. SETI early days were scattershot pointing telescopes at random stars, hoping for luck. Now, missions like TESS and Kepler have handed us a catalogue of thousands of exoplanets, letting astronomers focus on worlds with liquid water or stable orbits. If WOW was a message, today's telescopes wouldn't just hear it, they'd know exactly which star system to blame. Yet for all our advances, the WOW signal retains its edge. It's a reminder that brilliance isn't just about processing power. Ehman's sharp eye and that red pen did what no algorithm could. They recognized sheer, jaw-dropping strangeness. Modern tools might solve the mystery faster if it ever happens again, but until then, the WOW signal lingers as both a relic of analog ingenuity and a benchmark for how far we've come. The real question isn't whether we'd detect it today, it's whether we'd still be left saying, wow. What if the WOW signal wasn't just cosmic static? What if it was them? The moment we confirm an extraterrestrial transmission, everything changes, not just for science, but for every human being on the planet. Philosophers have debated this scenario for centuries, but the protocols in place today reveal how unprepared we might truly be. Take the Declaration of Principles Concerning Activities Following the Detection of Extraterrestrial Intelligence, a mouthful of a document drafted by SETI scientists in the 1980s. It reads like a diplomatic playbook for first contact. Verify the signal, alert global authorities, withhold public announcement until confirmed, and above all, do not reply without international consensus. It sounds orderly, almost clinical, but in reality, the first confirmation of alien contact would ignite chaos no document could contain. Imagine the headlines. The social media storms, the religious reckonings. For some, it would be vindication, proof we're not alone in the universe. For others, an existential crisis. Governments might scramble to control the narrative, while conspiracy theorists would insist they've known all along. Economies could reel as industries pivot overnight. Space exploration budgets would balloon, while terrestrial squabbles suddenly seem petty. And then there's the fear. If another civilization can reach us, what else can they do? The same protocols that urge cautious optimism also quietly acknowledge this darker edge, because history shows us how first contacts play out on Earth, and it's rarely peaceful. Yet the real revolution might be philosophical. Proof of extraterrestrial intelligence would force us to confront questions we've only toyed with in fiction. Are we special or just one voice in a galactic chorus? Does human life have purpose in a universe teeming with unknowns? Even our concept of time would warp. That signal, if artificial, could have been sent millennia ago by a civilization already extinct, making their message less a hello and more a gravestone. Or worse, it might be a relic of a society so advanced we're like ants trying to decode a satellite transmission. The irony is this: the WOW signal's greatest power isn't in what it says, but what it reveals about us. We've built protocols and telescopes and theories, yet we're still children holding a seashell to our ears, straining to hear the ocean. Whether the signal was alien or not, it's already done its job. It's made us wonder and fear and dream. And that, perhaps, is the most human response of all. Every unexplained phenomenon breeds conspiracy theories, and the WOW signal was no exception. Almost as soon as Jerry Ehman's red pen touched that printout, whispers began swirling that governments knew more than they were letting on. Some theorists pointed to the Cold War-era secrecy surrounding space technology, arguing that a signal that clean, that precise, couldn't have slipped past military surveillance unnoticed. Declassified documents from the 70s revealed just how paranoid superpowers were about extraterrestrial contact, not out of wonder but fear. A 1978 CIA memo, obtained decades later, explicitly warned that UFO reports could be exploited by adversaries to manipulate public opinion. Against that backdrop, it's easy to see why WOW became a magnet for cover-up claims. Then there's the curious case of Big Ear's sudden demise. Just 6 years after detecting the signal, the telescope was dismantled officially due to funding cuts. But conspiracy circles seized on the timing, alleging it was silenced to prevent further discoveries. Never mind that the land it sat on was sold to expand a golf course. For true believers, the shutdown reeked of a calculated gag order. Even Ehman himself noted wryly, they didn't need to bulldoze it to keep us quiet. They just stopped paying the bills. The most persistent theory involves a shadowy group within NASA, allegedly code-named Sigma, tasked with assessing extraterrestrial threats. While no direct evidence links Sigma to WOW, leaked Pentagon slides from 2017 referenced a potential non-human intelligence assessment program, fueling speculation that the signal was analyzed far beyond public scientific circles. Former intelligence officials have added to the intrigue. In a 2020 interview, a retired NSA analyst using the pseudonym Observer X claimed the agency intercepted anomalous signals matching the Ohio event as late as the 90s, though he provided no documentation. But here's where skepticism collides with sensationalism. For every tantalizing lead, there's a mundane explanation. That CIA UFO memo primarily concerned with Soviet disinformation, not alien contact. The Pentagon's Sigma slides, later attributed to a speculative think tank, not active policy. Even the notion that governments could suppress a global revelation strains credibility, since when have bureaucracies been that efficient? The real irony is that the WOW signal's stubborn mystery doesn't need conspiracies to fascinate. Its power lies in what we don't know, not in imagined cover-ups. Yet the theories persist because they tap into a deeper unease. In an age of satellites and quantum computing, the idea that something could still defy explanation, that the cosmos might hold truths no one controls, is either thrilling or terrifying, depending on who you ask. The WOW signal doesn't just haunt astronomers, it unsettles the very systems we trust to keep us safe, leaving us to wonder if this was a secret who's really being kept in the dark. The mystery of the WOW signal might not stay unsolved forever. New eyes are turning to the skies, armed with technology that would have been unimaginable in 1977. Take the Vera Rubin Observatory, set to begin its 10-year legacy survey of space and time in 2025. Unlike traditional telescopes that focus on narrow patches of sky, Rubin's wide-field lens will scan the entire visible sky every few nights, capturing changes too subtle for older instruments to notice. If something like the WOW signal happens again, whether it's an artificial burst or an unknown natural phenomenon, Rubin could catch it in the act, triangulating its origin with unprecedented precision. But here's the catch: Rubin is designed to detect light, not radio waves. Its strength lies in spotting anomalies, the flicker of a distant megastructure, perhaps, or the infrared glow of an engineered heat source. Even if it doesn't hear the cosmos, it might see what we've been missing. Then there's the Square Kilometre Array, or SCAR, the most ambitious radio telescope ever conceived. Slated for full operation by the late 2030s, its thousands of antennas across South Africa and Australia will create a listening dish with 50 times the sensitivity of Big Ear. SKA won't just pick up faint whispers, it'll dissect them, analyzing polarization and modulation to distinguish between cosmic static and something more deliberate. If a signal like WOW flares up again, SKA could trace its path back to a specific star system or even detect secondary pulses we've previously overlooked. The irony: SKA's sheer power might overwhelm us with data, burying the needle of an alien signal in a haystack of natural oddities. Yet the biggest revolution might come from AI-driven SETI initiatives. Projects like SETI Cosmic, currently deployed on the Very Large Array Use Machine, learning to sift through millions of radio channels in real time, flagging patterns no human could spot. Unlike Jerry Ehman's red pen, these algorithms don't get tired or biased. They're trained to recognize anomalies that don't fit known astrophysical templates, not just the ones we expect to find. Even more tantalizing are efforts to apply quantum computing to the search. Quantum algorithms could analyze vast datasets for hidden correlations, maybe even decrypt a signal structure if it's encoded in ways classical math can't crack. Still, the question lingers, what if WOW was a one-off? The universe is under no obligation to repeat its tricks. Some phenomena like colliding neutron stars were theorized decades before we witnessed them. Others, like certain types of supernova, appear once in a galactic lifetime. If the WOW signal was the cosmic equivalent of a lightning strike, we might never catch its like again. That possibility forces us to confront a deeper truth. Science thrives on reproducibility, but the cosmos doesn't care about our textbooks. Some mysteries endure not because we're not looking hard enough, but because they're woven into the fabric of a universe that's vast, strange, and indifferent to our craving for answers. The future of the WOW signal isn't just about better telescopes or smarter algorithms. It's about redefining what counts as evidence in a universe that keeps defying our expectations. Maybe the next WOW won't be a radio burst at all, but a flicker of light, a gravity wave, or a particle stream we don't yet have the tools to interpret. Or maybe, just maybe, we'll look back in 50 years and realize the answer was in front of us all along, buried in the static of a 1977 printout, waiting for a perspective we hadn't yet invented. Until then, the signal remains both a beacon and a taunt, a reminder that some truths refuse to be hurried, no matter how loudly we listen. While professional astronomers debate the WOW signal in journals and conferences, some of the most passionate investigations come from backyard observers and amateur sleuths. Take Robert Gray, a Chicago-based data analyst who spent nights hunched over his homemade radio telescope, pointing it at the same patch of sky where Big Ear caught the infamous burst. Gray didn't just scan for repeats, he wrote books, crunched decades of data, and even collaborated with SETI researchers, determined to prove the signal wasn't a fluke. His dedication turned him into a folk hero among citizen scientists, though he'd be the first to admit his efforts haven't turned up a second WOW. Then there's the story of the WOW Signal Hunters, an online collective formed in 2012. This global network of hobbyists pooled their gear from repurposed satellite dishes to university-caliber receivers to monitor Sagittarius around the clock. Their makeshift antenna array spanned 3 continents, with members tagging in for shifts like cosmic night watchmen. One participant in New Zealand even rigged an alert system to ping her phone if her setup detected anything matching WOW's profile. The team logged thousands of hours catching meteor showers, satellite glitches, and even a few unclassified military transmissions, but never that elusive 72-second Enigma. The rise of crowdsourced science platforms has given these efforts new momentum. Projects like Zooniverse's SETI Live let anyone sift through real telescope data, hunting for anomalies missed by algorithms. In 2021, volunteers parsing archival Arecibo recordings flagged a handful of narrowband signals eerily close to WOW's frequency. Though later traced to Earth-based interference, the discovery showcased how collective curiosity can uncover leads professionals might overlook. Other initiatives, like the Galileo Project's open-source sky surveys, encourage amateurs to upload their own observations, creating a living database of cosmic oddities. What's striking isn't just the volume of these efforts, but their emotional undercurrent. For many participants, tracking WOW isn't about fame or answers, it's about kinship. There's a shared thrill in staring at the same patch of sky that whispered to us 45 years ago, wondering if tonight might be the night it speaks again. Some keep logs in carefully dated notebooks, others maintain sprawling spreadsheets, but the ritual is the same: tuning in, leaning closer, hoping to catch the universe mid-sentence. The irony, while these citizen scientists haven't found a repeat of WOW, they've stumbled upon other mysteries, brief radio anomalies, unexplained spectral dips, that remind us how much static hides potential stories. Every dead end still teaches something: how to fine-tune equipment, how to filter out terrestrial noise, how to sit with uncertainty, and sometimes that's enough. Because the signal's true legacy might not be in solving a mystery, but in awakening the instinct to listen. After all, you never know when the cosmos might decide to whisper back. The WOW signal and modern UFO sightings might seem worlds apart, one a blip on a radio telescope, the other glowing objects darting through the sky, but look closer and eerie parallels emerge. The US government's 2021 UAP report confirmed what many had long suspected. Unexplained aerial phenomena are real, even if their origins remain unclear. Like the WOW signal, these encounters share a frustrating elusiveness. They defy easy categorization, vanishing before we can pin them down. Both leave behind just enough evidence to tantalize, but never enough to conclude. Consider the similarities in how these mysteries behave. The WOW signal appeared without warning, then never repeated a cosmic drive-by. UAP, as described by Navy pilots and radar operators, often do the same: sudden appearances, impossible maneuvers, then silence. The Nimitz encounter in 2004 featured objects accelerating from 0 to hypersonic speeds without sonic booms, as if physics itself had taken a coffee break. WOW's signal strength peaked and faded like a spotlight sweeping past. UAPs often flare bright on sensors before dissolving into static. Neither leaves debris, neither follows predictable patterns, and both seem to tease us with glimpses of something just beyond understanding. The Pentagon's recent disclosures add another layer. Their UAP task force quietly admitted some incidents involve unknown signatures, a bureaucratic way of saying the objects emit energy or radiation we can't explain. That's uncomfortably close to WOW's profile, a signal too clean, too precise, too engineered to fit known natural phenomena. Even the language mirrors each other. Military reports speak of UAPs exhibiting advanced aerodynamics. Astronomers describe WOW's frequency as artificially narrow. Both fields, in other words, keep bumping into anomalies that look suspiciously like technology, just not ours. Skeptics rightly point out the gaps. UAPs are visual or radar blips, while WOW was a radio emission. One involves objects in our atmosphere, the other a signal from deep space. But what if they're facets of the same underlying strangeness? Imagine a civilization capable of interstellar communication. Wouldn't they also master propulsion that makes our jets look like horse carts? Perhaps the WOW signal was their hello, and UAPs are their drones, scouts sent to a planet that suddenly seemed interesting. Or maybe we're seeing disconnected fragments of something broader, like blind men describing different parts of an elephant. The real twist comes when you examine the timelines. WOW arrived in 1977 at the tail end of a UFO sighting boom fueled by Cold War tension and sci-fi mania. The modern UAP wave began in the early 2000s as sensor technology finally caught up to what pilots had reported for decades. Both eras share a common thread: moments when humanity's observational tools leap forward, revealing corners of reality we hadn't noticed before. Each time we find more questions than answers. What binds these mysteries together isn't proof, it's pattern recognition. Our brains are wired to seek connections even when the data resists. The Pentagon won't say UAPs are alien, just as Ehman never claimed WOW was a message. But both force us to confront the same humbling truth: the universe is weirder than our textbooks, and we're only beginning to learn how to see. Whether these phenomena are linked or just cosmic coincidences, they've already done their job prying open our imaginations to possibilities that once seemed like fiction. The real story isn't in the signals or the sightings. It's in what they reveal about us, a species forever straining to hear whispers in the dark, wondering if we're finally being answered. The wow signal lingers like a cosmic riddle, 72 seconds of radio waves that refuse to be forgotten. No matter how many decades pass, it's a mystery that taunts us with its simplicity. A signal so perfect it could be a message, yet so isolated we can't be sure it wasn't just the universe playing a trick. But that's the thing about great enigmas: they don't exist to give us answers. They exist to keep us asking, to remind us that the universe is vast and strange, and humanity's story might be just one sentence in a much longer conversation. Think about what we've learned since that summer night in 1977. We've mapped thousands of exoplanets, discovered water on moons, even heard the reverberations of colliding black holes. Yet the wow signal remains untouched by progress, floating stubbornly outside our understanding. Maybe that's its gift. In a world where algorithms predict our every click and satellites track every inch of the planet, here's something that defies categorization, a puzzle that humbles even the sharpest minds. So where does that leave us? Not with defeat, but with invitation. The search for extraterrestrial intelligence isn't just about finding aliens, it's about finding ourselves. Every time we point a telescope at the stars or train an AI to sift through cosmic noise, we're declaring that curiosity is humanity's superpower. Projects like SETI and Breakthrough Listen aren't just science, they're acts of hope. A bet that somewhere in the darkness, someone else might be listening too. And if they are out there, sending signals we can't yet comprehend, imagine what that means. The wow signal could have been a cosmic hello from a civilization that burned bright and faded millennia ago, or a flare from a species so advanced we're like ants puzzling over a flashlight beam. Either way, its legacy isn't in the silence that followed, it's in the questions that silence sparked. So keep looking up. Support the scientists straining to hear whispers in the static. Share the wonder with someone who's never heard of a 72-second mystery from 1977, because the universe doesn't owe us answers, but we owe it to ourselves to keep listening. Who knows, the next wow moment might be just one observation away, a flicker in the data, a blip on a screen waiting to remind us we're part of something bigger. Until then, the stars aren't just distant lights, they're possibilities, and sometimes that's enough.